Good day, my dear 9th class students. Few days back, I completed teaching you the chapter number 4, lines and angles. Very interesting chapter. Right after that, we are moving to chapter number 5, coordinate geometry. I have been very selective in what chapter I have to teach. As you know, the syllabus for this year is not 100% nailed down, but I am selecting such chapters that the study of which is essential for you this year as well as next year. That is 10th grade. That is which is the most important one. Okay? So you will be best assured that whatever you learn today or in this class is highly useful for your next class. With that, I would like to give a general comment. We have been recording the lessons. I think we have completed more than 120 videos in different subjects for different classes. We are on the roll. We are moving. There are 5, 6 teachers are working, plus the office staff, plus madam and her husband. They are all working. So well, we are working hard to complete this particular chapter in two parts. First one, I will explain what coordinate geometry is, and the second one, I will do some problems, just like what I did in chapter 4. So, this geometry, now you heard about geometry, coordinate geometry, plane geometry, three-dimensional geometry, like that. Now in this lesson or in this chapter, we are going to be limited in our discussion to plane geometry. Now here, this is also called Cartesian, there is a system called Cartesian coordinate system which we use in this particular chapter. This is based on a mathematician in the 17th century. His name is René Descartes, which in short you can call it as Cartesius. So because he invented this, it's a major breakthrough in mathematics, connecting the geometry and algebra. So this Cartesius, who invented this, and the coordinate system, he is calling it as Cartesian coordinate system. It is very simple, and you are now in the 9th class. Actually, you have been using the Cartesian coordinate system probably for the last 4 or 5 years, not knowing the name. But when you conduct an experiment in a laboratory, if you want to, like a photosynthesis experiment, or when you have two variables, you want to find out what is the relation between the variables, you conduct an experiment and then you plot the values on a graph paper. There you are using the Cartesian coordinate system. Okay? So, in a sense, you are already used to this Cartesian coordinate system, and we are going to study this chapter as a chapter in mathematics, not a chapter in social studies or science. Okay? All right. Let me move on. After this, we have in the Cartesian coordinate system, again I told you, we are limiting ourselves to plane geometry. Plane, this is one plane, the plane geometry. Then you have the three-dimensional geometry. Three-dimensional. That means there are three dimensions, x, y, and z. In the coordinate, in the plane geometry, you have x and y. This is very useful. Now, let me see. In the coordinate geometry that you already know, you draw a line like this, and a line, horizontal line like this, and then a vertical line that is intersecting this line. This point here, this point you call it as origin. This is called origin. Where a horizontal line meets with the vertical line, that point is called is the origin. This one is called as x-axis. Now if this is a positive side and this one is x dash, that means on the negative side. Now similarly here, this is y, or call it as y-axis, and this is y dash. All this you know. So this is origin, this one is x-axis, this one is y-axis. If we are going downward, then y becomes negative, and if we are going to the left, x becomes negative. So here, when you mark the dimensions, like for example, like 3, 4, 5. Similarly here, 1, 2, 3, 4, 5. 5 equal places. So here this is 1, this is 2, this is 3, this is 4, this is 5. Like that. You can mark as many number of points you want. Here on this side, this is -1, -2, -3, -4, -5, -6, like that. You follow me? Now, on the y-axis, again, you use 1, this is 2, this is 3, this is 4. Similarly, on the downward direction, it is negative. -1, this is -2, this is -3, this is -4, this is -5, this is -6, like that. So, these are the values of the x-axis. When you go from the origin to the right-hand side, they're all positive. Again, from the origin, when you go to the left-hand side, they're all negative. In the case of y-axis, from the origin, when you go upwards, they're all positive. When you go downwards, they're all negative. All this, almost, you know this. Okay. Now, this x, the value of the x, this one is called abscissa. A-B-S-C-I-S-S-A. And whereas for the y-axis, it is called ordinate. I will get to that. Let's just wait for 1 second. Okay. Now, in the Cartesian coordinate system, any point in a plane can be referenced as having two coordinates, x-coordinate and then y-coordinate. So, in the Cartesian coordinate system, any point on the plane can be located with two numbers. One is x-coordinate, another one is y-coordinate. It is a universal practice to state the x-axis first, x-coordinate first, and then the y-coordinate next. Suppose I take a point here, let's say this one. I take a point this one, and this is about, let's see, a point here P. P is represented as xy. That means always you represent the x-axis, the value first, and then the y-axis. Suppose if you take here, so here the value of x is 1, 2, 3. So this is also called as P3, and y-axis is 1 and 2. So P3, 2. You see that? That's how a point is represented. This point is represented in the Cartesian coordinate system. Suppose I have, let's say, q minus 5 and 2 or 3. Let's say minus 5 and 3. So that means the x coordinate is minus 5, y coordinate is 3. So x coordinate 1, 2, 3, 4, 5. That is this one, and y coordinate is 3. 3 is this one. So if you draw a line parallel to x-axis like that, and if you draw a line parallel to y-axis, this point is called q, and this is minus 5, 3. You see how, given a point, given the coordinates, the point is already decided. Nobody can change it. When God comes here, he has to mark it P32 means 3 points, 3 units on the x-axis and 2 units on the y-axis. That's how the point P is represented. Suppose you have R, another number, let's say, another letter R. R is, let's say, minus 5 and minus not 5, minus 4 and minus 3. Let us say minus 4 and minus 3. So this is what? This is the x coordinate, that is the axis R, and this is the y coordinate, or RD, called as the ordinate. Minus 4. This is minus 4. You draw a line like that, and then y-axis is minus 3. This one. So this point is R. You see that? So minus 4, minus 3 is here. All this you know. I'm just trying to review that, reinforce your concept about this, so that you will, when there is a problem, you can easily handle that. So now, lastly, I will take another point. S is equal to S1 minus 1 say. S is 1, here this is 1, this minus 1 is this. I'm just trying to, I will do something different. Minus 1 and let us say minus 2. 1 and minus 2. This is 1 and minus, because it's studying and intersecting here, it may cause, so this is S. S is 1 minus 2. S is equal to 1 and minus 2. That's how the numbers, any letter, any point in the coordinate system is represented by two coordinates. HP is called, in general, we call it as P, X, Y. Whereas X is the axis, Y is the ordinate. So depending on the values, you can say in which coordinate it is. Here you can see both of them are positive because x-axis is positive, y-axis is positive. So this is this quadrant. So the whole space is divided into 4 quadrants. So this is the first quadrant. In the first quadrant, you have everything x positive and y also positive. This one is the second quadrant. In the case of the second quadrant, you have x-axis is negative and y-axis is positive. That is one. So you can see here minus 5, 3. Now in the third quadrant, this is negative, this is also negative. Both are negative. So that is the third quadrant. Similarly, finally, in the fourth quadrant, in the x coordinate is positive and y coordinate is negative. So this is the fourth coordinate. So you can see by giving the coordinates p, x, y, the values of x and y, you can locate the point, whether it is in the first quadrant, second quadrant, third quadrant, or fourth quadrant. And this is where all the numbers, all the letters are represented on a plain graph paper. You should be able to, for this, we use a graph paper. So you take a standard 8.5 by 11 graph paper, then make them into 4 parts and mark this as the origin. This is on this side, you have x-axis, this is minus x, or sometimes x dash. This is y, or this is minus y, or y dash. Okay? And this one is the origin. The x-coordinate is also called abscissa. Y-coordinate is called ordinate. So by having the coordinates, we can easily locate a given point, whether it belongs to the first quadrant, second quadrant, third quadrant, or fourth quadrant. Now, that means here, I gave you the general notation and all that. Suppose, let me see, how do you plot these points? How do you plot this point? You know all this, but just again, I am reinforcing your thoughts and to try to cover the syllabus here. Given a point, suppose you are given a point P, 2, 5. So what you do is, take your graph paper, divide into four segments, okay? This is one middle of the line and this is also a middle one. This point is 4, so you have 1 centimeter, 2 centimeters, 3 centimeters like that, and here you mark 1, 2, 3, 4, 5, 6, 7, whatever you get. So you mark them here, 1, 2, 3, 4, like that. This is 1, 2, 3, 4, 5, 6, 7, like that. So similarly at the bottom, these are minus, and on the left hand side they are all minus. Suppose you are given a point P2, 5, what it means is, you go 2 units. You go 2 units along the x-axis, okay, and then parallel to the y-axis, you go 5 lines. So 5 points, that means here. So in other words, you draw a point here, this is your point to P. So that's how a point with the given coordinates can be located on a graph paper. So this is very important when you go to the next class. You have in the coordinate geometry solution of equations, linear equations, and all these solution by graphical method, by using the Cartesian coordinates, and some other methods. But you can solve some of these linear equations using the coordinate geometry. Now here I want to tell you this coordinate geometry is so important. If you remember the war between America and Iraq, America could target a point, military quarters point in Iraq, and bomb that precisely. You see, when you send a bomber from United States, perhaps it has to travel maybe 5, 6, 7,000 miles and then hit the target. How is it doing it? When the bomber travels from United States, it takes care of all weather conditions. When it is, sometimes there may be some, storms, some lightnings, all that. There is a computer chip inside the bomber. It finally arrives at the target point defined by the coordinate coordinates. So given the coordinate, there is a 3-dimensional, there are other coordinates are also involved, but the basic fact is it is based on the coordinate geometry. So the moment, like for example, if I say a chart piece here, so it has three coordinates. One is the horizontal coordinate, x coordinate, and this is the y coordinate. And then suppose you are talking about the height also. This is a plane. Let me see. I will explain slightly differently. This is a plane, and you have the x-axis and y-axis. Suppose I have a chart piece here. I can show that x-axis, y-axis, and then z-axis. That's three-dimensional coordinate geometry. So using that, that's how they did it. They could destroy the military quarters using the coordinate geometry, Cartesian coordinate geometry. So this is a very, very simple chapter, very easy chapter. Here again, this is invented in 17th century by Rene Descartes, and that's in short, it is called Cartesius, and the coordinate geometry he invented, so it is called Cartesian coordinate geometry. Cartesian coordinate geometry is a geometry where a point can be located or identified by giving its distance along the x-axis and also along the y-axis. Once you know these two distances, the point is automatically decided. Like I said, if you just, let's say P15, that means you go P1 and then 5 units. So this is your, P, point P, or I will call it as R. Okay? R, this is R. So you go 1 unit along the x-axis and 5 units along the y-axis. Here I want to tell you that suppose there is a point, let me see, this is the draw paper. I want to, what are the coordinates of this point? This point is, let us say, this is 1, 2, 3, 4, 5, like that. Now here, for the point on the x-axis, you have what is the coordinate here? P, 3, and y coordinate is what? 0. So P3, 0. Where the y coordinate, if the y coordinate is 0, that means the point is lying on the x-axis. Similarly, I call it a P07. P07. That means the x coordinate is 0. All I do is measure 7 units here. This is my, instead of P, I will say T07. So the point can be on the x-axis or y-axis or somewhere in between. Can anybody guess what is the coordinate for the origin? Origin is 0 and 0. X coordinate is 0, y coordinate is 0. So we have learned about how to represent given a point on the graph paper, locating it, and in the next presentation, I will do some problems. And in the coordinate system, every point is represented by two coordinates. One is called the abscissa, that is along the x-axis. The other one is the ordinate, that is along the y-axis. And the intersection where the x-axis and y-axis meet, that is called the origin. I hope you understood the presentation. If you have any doubts, of course, like earlier we were saying, Srijana is always available 24 hours a day, 365 days a year. Okay? Don't hesitate to ask any question. The Srijana will be happy if you ask if any student or even a teacher ask a question. I would love to respond to you in the shortest possible time. Thank you. Have a great day.